Hello there. Before us we have a uniquely defined triangle by side, 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 and we want to find the area of that triangle. So there's different ways of going about this. I could drop a line down here, try to eventually calculate out that height, and do 1/2 base 28 times that height. I could go and figure out the angles involved here by side, side, side. I could use law of cosines to get the angles and do 1/2 AB sine C. But I'm going to show a new technique for this, and it works specifically for the side, side, side problems, and that's Heron's formula. So we need a little bit of shorthand here. In a triangle with sides A, B, and C, Heron has something called the semi-perimeter, which is the perimeter A plus B plus C all over 2. And Heron's formula says that the area is going to equal the square root of that semi-perimeter S times S minus A, S minus B, and S minus C. So all we're going to need to do for this problem is step 1, calculate that semi-perimeter. Okay, evaluate, and keep going. So we get our semi-perimeter is 35, and then we're going to take this 35 and plug it into our equation here. So inserting for S, we got 35, then parentheses, 35 minus the first length, we'll go 25, 35 minus the next one, 17, suppose we could put these in order, and 35, the semi-perimeter, minus that third length, 28. So it's a fairly long formula in some ways, but you have to remember the semi-perimeter part, but otherwise there's a lot of symmetry in it. It's always S, it's just S minus A, S minus B, S minus C, and then you have the original S out in front there. Okay, let's simplify that. And that's just a long string of multiplications, so let's multiply that out, and take the square root of that. Whoa, and in this case we actually wound up with an integer area, which very rarely happens, but that's pretty slick. All of these sides here are integer lengths, and our area is also an integer, so this actually has a special name. This is called a Heronian triangle, because it's all integers, and that deserves a smiley face. Character and Scholarship for Life.